So, hello and welcome everyone to another session in the DataHour series. We are also thrilled to be here with you this evening for a session full of action-packed learning. I am Tamil Selvan Murugesan, part of the data science team at Analytics Vidhya, and I will be the moderator for this session. So, for those who have joined for the first time, let me give you a brief introduction about the DataHour sessions. The DataHour is a series of webinars conducted by Analytics Vidhya, led by top industry experts. It is a fun way to understand the concepts of data science from the leading players in the data tech domain. As the name suggests, it's 1 hour dedicated to data. We are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. So now about the session today, which is product-oriented data scientists. So in the world of data science, for every problem, we can either have just a solution or a product. The value we can add via product mindset is exponentially more than just the solutioning piece. So this data hour will involve how data science needs to go beyond solutions and have data products instead. We'll have a scenario-based understanding of how to create a solution for a problem and then take it a few notches up as a data science product and other various nitty-gritties. For participants who are interested, we'll also discuss opportunities to co-create data products. In summary, this session would be about how participants can follow the pathway towards achieving a data product mindset. So now onto our speaker. In this session of DataHour, we have Mr. Sabitra Pandey with us. So Mr. Sabitra is a seasoned data innovator having almost 50 years of experience in this field. He is the co-founder, CEO, Chief Data Scientist at Vital IQ Analytics, a boutique data innovation firm. He has completed his engineering from NIT Rourkela and MBA from IIM Indore. He has multi-domain data science experience by working for Accenture, Lenskart, Goldman Sachs, National Instruments and Standard Chartered. He has set up the analytics division from scratch in Lenskart, which is a unicorn. He has also led the global data teams in many of the companies mentioned above. He has an avid interest in training and has trained more than 500 people globally in data science. He is a visiting faculty in many B schools for the same. So before we kick things off and I hand it over to our speaker, a quick recap of the housekeeping items. We are recording this session and we'll make the recording available in a few days on our YouTube channel. Please use the Q&A section for asking any questions you might be having during the session, and we'll do our best to answer them as the data hour progresses or towards the end. Also, we'll share a feedback poll towards the end of the session, which I request you all to kindly participate in. So over to you, sir. The virtual stage is all yours.
Thank you. Am I audible?
Yes, sir, you are audible.
Okay, sure. So let me share my screen real quick.
Your screen is visible, sir.
Okay. First of all, thanks a lot, Analytics Vidhya, for hosting me, and a warm welcome to all the participants who have joined over multiple nations globally. I hope that I do justice to the next 1 hour and we all go back enriched, right? That being said, I think my introduction has already been done, and 15 years is a long time in the world of data science to understand the nitty-gritties. And since the last few years, what I have noticed in the world of data science is things are moving towards data science product creation more than they were ever before, right? So it makes all the more sense to understand what is a product-oriented data scientist, or rather, who is a product-oriented data scientist, right? And should we aspire to become one of those, right? That being said, let's quickly go through what we have in the next 1 hour. So these are the possible themes we plan to cover. The introduction part is done. What we will do is we will understand and set the expectation of what to expect in the next 60 minutes. We will try to understand how a data science product is different from a SaaS, PaaS, and IaaS. Now, SaaS stands for Software as a Service, PaaS stands for Platform as a Service, IaaS stands for infrastructure as a service. So how are they different from a data science product? We'll also try to understand the current scenario, which is evolving. We'll try to understand how a full stack data scientist is different from a product data scientist. We'll talk about the persona of a product data science. Now, this is very important because once we understand the persona, we know that what we need to learn to become one, right? Hopefully everybody understands the word persona. Now, we will go into the industry examples of data science products, right? Most of what we have implemented. And I'll show you certain snapshots of that so that you people get a fair idea of what a data science product can look like, right? We'll understand how to take the next leap, which is the way forward. Last but not the least, we need to answer the question, what is it there for me, right? So point number 9 is where we will talk about industrial opportunities for data science product creation. So if you people are going to pick up one point out of these, it should be the 9th point, because that tells you, okay, what are the opportunities for me to become a data science product creator, right? And then we will try to end it up with the question and answers. So we have a significantly packed schedule. So let's just get rolling. So as the introduction went by, so I am the co-founder and chief data scientist and also the chief operating officer at ByteIQ Analytics, which is a boutique data science and data innovation firm, basically. So we deal with data innovation, and we have data science wherein we deal with data engineering, AI, ML, data visualization. We also do data science training globally, where I myself have trained more than 500 people in the last couple of years. So what have we learned over time is what I will try to pass it on to you in the next 1 hour. And once we are done, we should be able to answer these 3 questions: what, why, and how of product data science. So the expectation that I want to set for this session is, in the end, I want people to ask questions, because I don't want it to be a one-way traffic, right? I want people to participate and ask questions. I cannot guarantee a silver bullet. Basically, I cannot give you a magical solution that will cure all the problems, right? This session will not be highly technical. There won't be things which are easily available on the internet. There won't be extensive coding, right? So you can rest assured these things won't be there. What will be there is, it will be kind of a navigation or a guidance of what I have learned over the last 15 years and how can I pass it on to you. This will be more example-based scenarios which will help you understand more easily, right? And we will keep it very targeted and relevant. That's all we want to have in this session, right? So now, you'd be curious, right? How is a data science product different from the IAS, PAS, and SAS product? So before that, let's take an example and understand what's a platform as a service. Many people would have heard about Adobe Commerce, which was earlier called as Magento. It was a PHP platform on which you could host your e-commerce website, create all the cataloging and everything, right? One of the earliest e-commerce platforms that I worked for was hosted on Magento as well. That was platform as a service. When we talk about Gmail, Microsoft Office, we are talking about software as a service. And when we're talking about the cloud platforms like Azure, GCP, AWS, we're talking about infrastructure as a service. Now, how is a data product? Can you give me an example of a data product? I can give you an example, Google Analytics. I'm not sure how many of you are familiar with Google Analytics, right? When you host your website, there could be people coming in, the traffic coming to your website and stuff like that, right? So how do you analyze those? How do you analyze the impressions? How do you analyze the visitors, the visit, etc.? So you do it through Google Analytics. That's a data product. Now, what could be a few more examples of successful data products? You all would be familiar with autocorrect on your phone, the spell check on the computers, the recommendation system, right? When you try to go through any e-commerce website, you get a recommendation. You may also like this versus you may also like that. So those are example of data products, right? And in reality, those can be divided into three major parts. And that is based on the outcome that they generate, right? If it is a pure service, you can take an example of Bloomberg terminals, where you get an idea about stock prices, right? Data enhanced products could be something that converts a physical or a virtual product into something more enhanced, like you convert your car into a self-driving vehicle, right? So that becomes a case of data enhanced products. Data as insights, again, as I mentioned, Google Analytics, right? You get insights out of data, like how is my visitors number going up, is it going down, etc. So that's how a data science product is different from a SaaS, PaaS, and IaaS. So as I mentioned, let's take the example of the last 5 years. We note that there has been a sudden focus on database products, right? But why? So it has so happened that organizations have started storing data for a long time. And since the last few years, they've started realizing the economic value of those. So you keep on hearing terms like data is the new oil, this and that. So how do we invest more into data products so that we can maximize the value of those economic assets, right? So now, what we earlier used to think that data can be monetized, but it can be better monetized as a product. Hence, many organizations are pushing towards the data product, right? You'd also hear terms like embedded analytics integration, which means your analytics doesn't need to exist in a separate product. It could be integrated with all the in-house systems that you have, right? So we'll see the examples of that when we go forward. Now, typical question that should arise in your mind is, okay, I'm a data scientist. I have had my model output. Isn't that what I'm expected to end with? A typical data scientist would think, okay, my model is created, the output is there. Let's take an example, a classification output. Things are classified, my job is done. No, it's not. When we think about a model output and a possible data product that can be created, we see a huge gap. And I'm talking about this gap. Most people do not, and most data scientists do not think beyond this. So what do we do so that we can bridge this gap? This gap can actually be bridged by something called a data science product strategy. Now, data science product strategy is very unique and it has 3 parts. So if you see, the 3 parts are market needs, key features, which are differentiators, and a business goal. Now, when somebody wants to create a data product or data science product, it should equally balance on all the 3. Because if I'm working for XYZ organization and I'm trying to create a data product, it should first of all meet the business goal of the organization. Let me give you an example. Let's say that the organization has a mandate of trying to disburse loan, right? It wants you to build something that will classify applicants as, let's say, loan can be given to him or loan cannot be given to him, right? So that's the business goal. if there is a deficiency in that area, you should probably build a product that should cater to that, not something else. Now, if you're building something, you should always evaluate, does the market need it? If there is no usage of such a product in the market, why am I spending resources building it? The third being key features and differentiators. Now, if my product is a copy of somebody else's product, or there's no differentiation in my product, why will someone be interested in my product versus something that already exists in the market? Do you think I'll be somewhat successful if I try to copy Gmail and create something similar? No, because it's a product that's already successful. It's there in the market. For me, there is no incentive to duplicate it and become famous, right? That's where your key features or differentiators become very important for a data science product. I think there's some Q&A. Okay, I think we have answered that. Fine. So with that, let's understand how a full stack data scientist
Hello. Hello, sir. You are not audible. Hello, sir. Guys, give us a minute. I guess the speaker has some internet problem. Hi, sir.
am I audible now?
Yes, sir. You are audible now.
Sorry,
Yes.
there was a network drop.
Yes, sir.
Right. So let me reshare my screen.
Sure, sir. Sure. Please go ahead.
Right. So I think I'm not sure where I was last, but I think I was talking about the journey of a data scientist, right? So it starts with the business problem. Then we do the data collection, the EDA, then we build the model, we test the model for all the metrics, we do hyperparameter tuning, etc., and try to find out the best possible model for our scenario. Then we deploy it and monitor it. Now, I'm not sure how many of you are aware of model monitoring, but that's a very, very important aspect, right? Many people are not very clear on those aspects. So model monitoring basically takes care of four major things, right? It takes care of the variance in the deployed data. When source data is not as clean as the training and test data later on, right? Changes in the data integrity. Now you built your model, there is a certain test and train data, but later on, let's say 1 month down the line, there is data where formats have changed, fields have been renamed, new categories are introduced, etc. And you also take into consideration data drift. Data drift is something because there are changes in demographics, market shifts, etc. Your training data becomes less relevant. When that happens, your model precision goes down, right? Also, there is something called a concept drift, which means your end user, who is the one who decides, he has certain expectation what constitutes the correct prediction, and that can change over time, making the model less relevant. So a regular model monitoring and retraining is required, right? So that, and there are questions. Yeah, we'll come to that. We'll come to those APIs. Is the voice a problem now? Am I audible?
Yes, sir, you are audible. You are fine.
Fine. So a product data scientist is someone who takes these a step further. Product data scientist is someone who doesn't stop at my model output is my endpoint. He doesn't have that mindset. He or she doesn't have that mindset, right? I'm giving you an example of why we should not be very, let's say, solution oriented. So solution is, let's say, the output from your model, right? And your model is not exactly your solution. So I'll give you an example, right? So let us say you have a shopping app where you need to, where people can scroll and they can like a product, they can dislike a product, etc. Now you have to show top 20 products for a particular user. But your business wants to show some promoted products as well, right? As it happens in Amazon, you would have seen promoted products, Amazon, Flipkart. So when the business wants to show a promoted product, that product, because it is new, will never feature in the top 50, let alone the top 20. So if I was very fixated with my model output, that particular thing would never be shown to the user. But are we trying to arrive at a model output, or are we trying to arrive at a solution? So when we are trying to arrive at a solution, my model should be able to accept the the promoted products as well. So basically, a change in the thought process is required. And what is that change? When you build a solution, most likely you'll build it for your own organization, because the data type could be a fixed data type, like let's say a set of data, fixed set of data. The problem could be a fixed set of problems that you're trying to solve. Now think of the entire market. So the solution that you develop for your organization, is there a chance that there could be a bigger picture to it? And when I say bigger picture, can I target the entire market? Can I build a product? Now, when I build a product, it can also mean that it can be consumed within my organization. It can be used outside if it's a generic product. Now, why I brought this point in that if I build a product, it can be used within my organization, because your end user may not be a data scientist. You should always remember that my end user, the end user of my product, may not be a data scientist. He or she could be the person in the sales department. He or she could be the person who is deciding on whether a loan should be rejected or accepted. Do you think it is easy for him or her to understand your model output and then take a call? Or do I provide him or her with an interface where he or she can put the values or the details of a particular applicant and then get the output? Right? So for that reason, why is it important to have a product mindset? Now with that, what we can do is we can build on the commonalities of my product versus some of the other attributes in the industry, which will help it make a industrial product. And last but not the least, what it will also give rise to is the IP angle. IP is intellectual property. So I'm not sure how many of you are aware of intellectual property, But when we talk about intellectual property, they are basically categorized into three categories. One is copyright, which majorly deals with the literary and artistic work protection. There's a trademark, which talks about distinctive signs like a symbol, etc., a company logo, etc. Then there is patent, which is generally applicable for industrial properties and products. Patent takes care of inventions, industrial designs, trade secrets, etc. So my ultimate goal should be, why can't my product be patentable? Right? And when we talk about innovation, one of the key aspects of innovation is how many patents do I have? So every country or every company is also ranked on the innovation index. And the number of patents is a big contributor towards that. Right? Now let us understand what should be the persona of a product data scientist. To a certain extent, he or she could be as similar as a normal data scientist. Like, you're expected to understand the business problem. You're expected to have certain basic data engineering abilities. Now, when I say data engineering, it's about how do I get data from multiple sources into a consumable format for my model to read. He or she should possess certain abilities in statistics and machine learning, which should enable him or her to create a comprehensive data science solution. Now that is where the journey of a product data science starts. Product data scientist always thinks about the end user, which in turn also is how usable would be my efforts or the product. So the ability to create an attractive visual layer for end user consumption is important. You need to completely automate the entire workflow from data extraction to the visualization layer. And if possible, make it as a product with basic front-end and back-end capabilities. Right. I think there are some questions. Fine. Now I'll give you certain examples that we have implemented. So we at ByteQ Analytics have implemented multiple data science products. I'll give you an example of those so that you people understand what those are. And I'll also share screenshots from there so that you get a basic idea of what that is. Right. So we did something revolutionary for the Indian banking industry. The challenge was multifold, where we had 70 different data sources with varied diversity. So the first challenge was the complexity of data engineering. The next was standardization of the quality. So when data starts coming from 70 different sources, there is a lack of standardization. The same bank could have a different name. There could be an extra dot, there could be a space, non-standardized names. Standardization. The third was data unification using a unique key was a challenge, since there was none. So our best bet was using the name. Right? Once that was done, the game of data science started post that. You had your data engineering done. Now we use our data science muscle to do three things. We created scoring models to generate scores. Now there were things like non-performing assets, other industrial growth, and so many, more than 150 dimensions we had, right? So it is important to score along those dimensions based on your trends and whatever was a data trends. Now it also became important to forecast. You can forecast, okay, maybe the loan portfolio is going to grow by 2x for this bank versus 1.5x for the other bank. Maybe the number of credit card users will go up by 15%, right? So all of those forecasts needed to be done, and certain predictive models needed to be built. But the most interesting part was the storytelling part. And when I say storytelling, it's not your standard visualizations that you have. How do I present a compelling story in the most simplified way? I can show you an example in the next slide, which I will right now. So this is a very powerful story called quad analytics. You would be imagining, what is this, right? So I'm taking an example and explaining it. So we are talking about the loans. We're talking about educational loans that a bank provides, right? So the bank gives you an education loan. So what we are doing is we're comparing two banks, and we can do multiple bank comparisons, right? We're actually comparing the journey over time. What you see is 4 quadrants. And I think everybody is familiar with the concept of quadrants, right? So these quadrants are leadership quadrant, emerging quadrant, struggler, and laggard. Now this is based on two things: the absolute value versus the rate of growth, right? So now if I look at a point in time, like let's say the latest data, I would see that the first bank is in the leader quadrant and the second bank is in the struggler quadrant. But that will not give me the complete picture. I'll never get to know was it always like that. So it's very important to understand their journey over time. So if you see here, both these banks started as laggards. And this was the journey of the first bank, which over time has moved on to the leadership quadrant, but this bank has struggled. It had gone to the leadership quadrant, but has fallen back. So this gives you a very lucid view of how the journey has happened. And this is the power of storytelling, right? For my end user, this would be far more beneficial than me quoting some standard model output. Now let me take another couple of examples. In a very interesting use case, which dealt with global accounting practices, we tried to use machine learning and deep learning for the purpose of anomaly detection or fraud detection. Now, why this was important is, till now, most of the fraud detection used to happen on a rule-based way. So there was a standard set of rules, and once you violate those rules, you used to be classified as fraudulent. So the anti-fraud measures were mostly rule-based. But the fraudsters have gone way ahead. So they have found out ways to deal with these simple rule-based techniques. So they're not as effective. That's where AI/ML comes into play. Not only that, this being a very complex area and most of the output being almost black box, there's a certain inherent risk. Let's say you classified certain transactions as fraudulent, and that was not a fraudulent transaction. That was somewhere very close to the false positive, but It was a borderline transaction and it belonged to a very senior person in the bank. Let's say, I'm just giving an example. So the consequences of that not being a fraudulent transaction, but being classified as one for a very senior guy could have consequences. Now that is the demerit of black box models, right? It will be very difficult to justify why something was classified as fraudulent or why a certain loan was rejected, etc. That is where the explainability comes into play, right? The explainability why certain things are classified as fraud is very important for an AIML model. And that is what we used. More so, what we also used is some of the tech architecture that we will talk later on after this slide. I'll show you certain. So if you look at this particular page, you get to see a app-like structure, right? Where you load your data set, your level of aggregation is defined. I'm saying where is a record level. I get to know what are, am I going to select my global outliers, my local outliers, etc. What is the model that I can select? Are these statistical model or are this deep learning model like autoencoders? Right? These are deep learning models. Now, something very common that you would have understood is the test train split. So here I can choose my test train split. Right now in this image, you see it's at 80-20 split. Right? So all of these kind of give you an app like look and feel where you can control your parameters and then the model gives you the output based on the selections you make. If I was doing this in my Python notebook, I would be really in a lot of mess trying to do a lot of iterations. Right? So this gives me a freedom from that particular mess. So this is one thing that I showed for the fraud analytics. I'll show you the other thing which I was talking about, the explainability. So as you see, we've used these three autoencoders and then the ensemble approach, which combines all three. So if you see, it gives you the density of anomalies. It also gives you time series view. Now let us see that senior executive was somewhere, let's say here. Then when I click on that, I kind of get to see the transactions and why it was classified as anomaly versus a complete black box model. That's where the explainability also plays a part. Last but not the least, we have developed something called an intelligent data forensics and excellence tool. The beauty of this tool is the Python packages were created from scratch. Compared to any, so most of the data forensics or data discovery tools, or let's say in a simplistic way, the data quality tools that you will get in the market are very basic. And all they do is data profiling. So the data discovery and profiling is very common across all the multitude of tools that you will get in the market. How is this differentiated? This majority, these are three segments. The first being the data discovery and profiling, which is common. The other two are the differentiators. We have something called a data shift indexation, which talks about the data drift with respect to historical data. Right? And I'll give you an example. Let's say the average invoice processed in a month earlier was in the range of $2 to $3 million. And now you are seeing something which is maybe 30% more than the historical values. So there has been a shift. And how do I classify or categorize those shifts? right? The next being the key data elements evaluation. Now, when I talk about KDE evaluation or key data elements evaluation, I'm talking about a quantitative score generation, which can be directly consumed. It's not a qualitative evaluation, it's a quantitative evaluation, right? So those are the three examples of how we have created data science products and not a mere solution. And all of these are like plug and play, which means with minor adjustments, it can be deployed in your data and it can be deployed in someone else's data. Okay, so now we're coming to the question, how would you take the leap from a solution to a product? So there are multiple ways of doing it. Maybe the tougher way and the easier way. So I'd always encourage you to first try out the easier way. This is the easier way. What does it say? Let's say your data science solution is already developed. What do? I hope everybody is clear with the pickle file, concept of the pickle file. Right? So you can save your model into a pickle file and that directly hosted in Streamlit. How would this look in Streamlit? This is how it would look in Streamlit. So this interface that you're seeing is nothing but a Streamlit interface, right? So Streamlit is a much friendlier alternative to Flask. You would have heard about Flask API, right? It's a much friendlier alternative to Flask, where you do not need any knowledge of web design tools like HTML or CSS. But you can take care of the backend and frontend through Python, right? So this is a complete Python-based frontend, which is done through Streamlit, right? The great thing about Streamlit is you can directly put your model in your GitHub repository and you can directly call it through Streamlit. It's that simple. But what if you require more polished way of doing things, right? Because Streamlit has its own limitations. It cannot be as sleek as some of the other tools, right? And that too, in a like when you go for a let's say more industrial application, it has its limitations. So what you can do is you can maybe put your data in a cloud RDS. You can also put it in your cloud data warehouses, but I think RDS would be a cheaper option. So again, try your Postgres in AWS, right, which is the most cost-effective way of doing it. So from the RDS, you could either use the cloud native visualization tools, right? If you're using AWS, it could be Amazon QuickSight. If you're using the Google Cloud Platform, it could be Looker, right? You can use Google Data Studio, which is completely free, right? So you can use your cloud native visualization tools, or if your organization has access to data visualization tools like Power BI or Tableau, that can be your end user interface, right? For example, if I'm building a churn prediction model, right, which can say, okay, based on these characteristics, this customer might churn out the next 3 months. So I can actually have the end user interface in Power BI or Tableau, which gives a very easy way for business to interpret who could be churning out next. How do I reach out to them through various offerings and kind of hold on to them, right? So this is the easy way of doing it. You use the cloud native tools or visualization tools, which can be again hosted on the server or Streamlit. But in one of our earlier examples or implementations, because it was commercial grade, we did it the hard way, right? Now from the cloud RDS, you need to connect to the front end. Now, the front end is built on React or Angular, right? You can use React or Angular, JavaScript front end. But for connecting your cloud RDS information to the front end, you'd require something like a fast API or Spring Boot. So the first option could be fast API, which is very lightweight and sleek, or Spring Boot. So my suggestion is try fast API, right? So this connection has to be done through fast API. Now what you can do is you can create microservices. Now what are microservices? So all of these could be put in a Docker image that can be hosted on your Elastic Container Registry, or you can host that on Amazon EKS, right? So whenever the user interacts, a call happens through this and information is fetched. So basically what the user gets here is a very, let's say, sleek and commercial grade front-end interface, either on Angular or React. So these are the use cases and the tech stack that we have used to kind of build our data science products. So now coming to the industrial opportunities that I spoke about in the first few slides. This is where the question that you asked is going to be answered. What is it there for me? So for people who really want to make their career in data science product development, so they could be freshers who are looking to get into data science, or they're data science professionals who are looking to become product data scientists. We are launching a co-create opportunity. So we are looking to create data science products along with you. So you would be the co-creator. And these products are across 3 different domains or sector, which I am kind of highlighting here. The first is going to be in the domain of in transportation or infrastructure. It's going to use computer vision. It's going to be a computer vision product in the field of transportation infrastructure. And for the people who want to co-create it, they would have a gamut of opportunities to contribute. They can contribute in the field of data engineering, AI/ML, which is the model development, the operationalizing and deployment of the model, and the integration if they want to kind of create a front end, right, as a product. And the approximate duration for it is 2 to 3 months. Similarly, we want to use computer vision in the field of education and a similar integration, but with a slightly higher tenure of 3 to 4 months. So these are the 2 products that you all can join to co-create with us, right? So you'd be one of the product creators in these areas. So you'll learn how to do it with our expert guidance as well. The third product is going to be slightly revolutionary, which is going to address the social sector or the gig economy. So gig economy is basically the blue collar workers I'm talking about, right? Here we are going to use a lot of statistical analysis with classical machine learning and optimization techniques. So this is not going to be computer vision, right? Here we'll have the data engineering, the AI/ML thing, and also the mobile app as the final product. Should be looking forward to build a mobile app as a product, data science product. This is a mobile app which is powered by data science, right? And it will take about 4 to 6 months of efforts. So people who are really serious about creating data science products, want to join us in co-creating, can actually email to this particular ID and we'll get back to them. So that's all about the product data scientist that we spoke. Now I'm open to the Q&A. So I think there.
Hello, sir.
Yeah.
Sorry to interrupt, sir. Before we take on the questions,
Yeah.
I'll launch a poll about feedback poll.
Sure.
I'll request the audience to kindly participate in the poll. Yes, sir. You can parallelly take on the questions, sir.
Sure.
Yes, sure. Yes, sir. I have launched the poll. You can parallelly take on the questions. The questions are available in Q&A section, sir. You can access the questions there.
Right. Okay, the last question is full-time or part-time course co-creation project. Again, it depends on how much time you can devote. Maybe a couple of hours per day should be. There's no time-bound duration. I mean, the time that we mentioned is 2 to 3 months, but maybe it can extend a bit. But it depends on how serious you are. So maybe a couple of hours per day should be good enough. But there is no, it's not a delivery to the client that needs to be done in 3 months flat. But yeah, more or less 3 months plus minus 1 month should be fine. So it depends on how much time you can contribute in a day. Okay, the second question is what tools to do the dashboards. Again, dashboarding can be done with a host of different tools, right? There are certain free tools and there are certain licensed tools. Now, I'm not sure how many of you are aware that even Python possesses a very strong capability to build beautiful dashboards. So you can do it for free using your Python libraries. And you can use it, you can use Seaborn, Matplotlib, Plotly. So there are a host of libraries you can use to create beautiful and dynamic visualization. There is, if you are using certain cloud platform, if you sign up for an AWS account, you get free credits. So you can still experiment using that, right? You can go for, so Power BI. Power BI is a free visualization interface as a desktop version, not as a server version, but as a desktop version, right? And even Tableau Public is available, but it's not encouraged for office or commercial use. It's for practice of students, right? And you can try it using Streamlit as well. Right. Isn't product data science more like MLOps? Not exactly. So when you talk about MLOps, you're talking about deployment and all these things. Product data science is not about deployment. So deployment is necessary step, but after that, you need to create a product which will have an interface for user interactions, right? MLOps will definitely not create an end user product, like let's say a Power BI dashboard or a Streamlit dashboard, etc. Right? Okay. What about the education profile of a data scientist as product? Okay. So there is no difference. There's no hardcore, let's say, what do we say? There's no hardcore differentiation between a data scientist's education profile and a product data scientist education profile. It's about the change in mindset and the willingness to take few further steps. So any normal data scientist can become a product data scientist. What is the one? How? Okay, I'm just trying to scroll up. As a data scientist, basic ability to utilize in digital augmentation to predict, analyze. I'm not sure if I understand the question. When you say product, does it mean all analytics platform which come with an automated dashboard like Fitbit stock app? It's a combination of, it's not about the analytics platform. So even your Fitbit is an example of a product, right? But not all products are similar. So there could be different products. So Fitbit is something which will give you information, right? So you can monitor your like body dynamics. Similarly, your stock apps will give you the market dynamics. Right? At the end of the day, the goal is to make information consumable to the end user in the most simplest way. Right? Be it through those apps, products, or even a simple Tableau or Power BI interface. Right. So in the second case, a simple Power BI or even a Python visualization interface could be a product or an app. Next question is, don't you think your vision for data science is extremely wide? I'm not sure I follow the question, but if it is about the data science product, then I think we have already, whatever products I spoke about, we have already kind of developed them, right? So yeah. The data science explored more community in SaaS and fast development. Okay, so George asks, could I go to the market with the MVP? Right. So in the world of startup, you would have heard two key terms, POC and MVP. Right? POC, so MVP could be the better version of a POC, if you could call it that way. So yes, when you go to the market, you at least in most cases, you need to have the minimum viable product. So the next step is to get users to your platform. So unless you have the MVP, you cannot actually get users to the platform. So yes, you have at least need to have the MVP to go to the market. Data deployment. Okay, model monitoring. The most straightforward way to do your ML model monitoring is to constantly evaluate your performance on real world data. Now you should have certain benchmarks that maybe my accuracy cannot go below this. Maybe my F1 score, my accuracy precision cannot go below a particular benchmark. Now, when that starts happening, that's a time to retrain our model. right? So model monitoring, which basically is another way of saying that is it time to retrain my model, is basically done on basically two types. Either you have a fixed schedule that maybe every 3 weeks or 4 weeks I'll do the retraining, or maybe I'll do the retraining when I kind of get a trigger or customized trigger that my metrics have gone below the threshold, right? I think the APIs part I have already covered. So you can use the best way to use best APIs you can use is fast APIs because it's the most lightweight. And if you want to use other APIs, it'll really require some bit of usage of tools that you would not be privy to. For example, maybe that HTML, CSS, etc. So my suggestion is if you are starting, then start with fast API. Right. So I think most of the questions are answered.
Hello, sir.
Yeah.
Yeah, are you done with the questions, sir?
Yeah, I think most of them.
Okay. Okay, sure, sir. Thanks a lot, sir. Thanks a lot for your timing and for your wonderful session. I'm sure that our audience had found it useful.
I think there are certain chats, certain questions in the chat. Maybe I'll take up a few of them. I think
Sure, sir,
they're
sure.
asking, is there any monetary charge for this project creation? Like we need to pay or do we incur during the course? No. So we will not charge a single rupee from you for work or co-working on the project. So it's absolutely free. And if you do a good work, there will be a financial reward from our end to you, not the other way around, right? So how much experience you need to become product data scientist? So let's say that you start, so when you start your data science journey, so before becoming a product data scientist, it's important to become a data scientist first. So maybe it will at least take you a couple of years to actually have that much ability as a data scientist because you start understanding the business problems. Then you also get a flavor of what my end user wants. So it will not happen overnight, but let's say somewhere greater than 1+ years in the field of data science will at least enable you to think about how do you connect the end user with the business problem, right? So that much experience. What are the other points? Some people are asking, they are BSc and MSc in the field of mathematics. Is there any future for me in the field? I think when we talk about statistics and machine learning, the application of mathematics, specifically algebra, is there, right? So, I mean, there's never a no to someone who has an interest to learn and become a ML person, or let's say a data scientist. So I think most of the people who have had a background in mathematics will find it really easy to become data scientists, right? Okay, I think that's most of that. So some people are saying it's not mentioned whether 1 is highest or 5 is highest. Yeah, fine. I think that's pretty much it.
Yeah, in the poll, sir.
Right.
Yeah, 5 is the highest actually in the poll.
Right. I think that's pretty much what was there in the chat and the questions. So hopefully everyone found it like useful. Thanks a lot for your time.
Definitely, sir. Definitely. Thanks a lot for your timing and for the wonderful session, sir. Like on behalf of Analytics Vidhya, I thank you very much, sir. Hopefully, we can conduct more such sessions with you in the future.
Sure. My
Sure, sir.
pleasure.
Yes,
Thank
sir.
you.
Thank you, sir. Thank you. Hello, everyone. If you hadn't participated in the feedback poll, please do participate. Yeah, sir. That's all. Okay, guys. I have posted all the useful links to the in the chat section. I have posted every coming DataHour series webinars. All those links are in the chat section. Also, I have shared LinkedIn profile of the speaker. If you wish to connect him, please do connect him with through LinkedIn. Yeah, that's it, guys. We'll be back with another session tomorrow. Hope we see you guys there. Thank you, sir. Thank you, everyone. Thank you for coming today.